depends on the t-shirts. So the cost is my dependent, and my t-shirts, number of t-shirts, is my independent. All right. Okay, so now we can take this information and we can use it to answer these questions here. So the first question is, what's the y-intercept and what does it represent? Okay, well, my y-intercept, remember, is always my starting amount in a situation, and I always mentioned that it would be part of your equation. It's the number that doesn't have the variable with it. So for the mighty T's, it's that, oh, I guess we got the equation right here. It's that $49 because we start off by paying $49. Okay, and for what it represents, we'd say the starting money. Okay, now for no shrink tees, they don't have a startup cost. They just charge $4.50 per t-shirt. So their y-intercept would be $0. Okay, and it also represents then the starting amount. So kind of put an arrow pointing at this. So in both scenarios, whether it's Mighty T or no shrink, they're paying a starting amount of money. Mighty T's pays $49. No shrink T's doesn't pay anything. Okay. Now it's asking what's the coefficient of the n and what it represents. So that's, again, what number is being multiplied with your variable. Well, this n does not have a number in front of it, but remember that's because it was $1 per t-shirt. We read that up here. So 1 times n would just look like n in the equation. So $1, that's my coefficient of n, and what does it represent? Well, it is my cost per t-shirt. Okay, every t-shirt was $1. Okay, in no shrink tees, the coefficient of the end is the 4.5, which if we're talking money, we would say that's $4.50. We could add the 0 on there. And again, that is still my cost per t-shirt. So it represents the same thing in both scenarios. Since n is the number of shirts, we're multiplying how much it is per shirt with that n. All right, so now we're gonna do some calculating with these equations. Now we wanna find the cost for 12 t-shirts. Well, in my equation, the n is the t-shirts, so I'm just substituting 12 where the n is. So I have C equals 49 plus, instead of n, sorry, we would put 12. Okay, so 49 plus 12. So I'm finding the cost, since that's what I'm looking for, so I'm plugging in my number of shirts. So 49 plus 12 then would make $61. So that's the cost for 12 shirts if we get them from Mighty T. Now if we do no shrink tees, then I'm going to plug 12, again, it's still in for n. I'm going to write C equals 4.5 times 12 and get my answer there. All right, so when I calculate this, I end up getting $54. Okay, so we got 54 versus 61. All right, so if they needed 12 t-shirts, we notice it would be cheaper for them to go with no shrink tees. Okay, then if we have 20 t-shirts, well, let's see what happens. Well, it's still the number of t-shirts, so I'm gonna plug it in just like the previous problem. So I'm gonna do 49 plus 20 this time, since they're $1 a piece, and so that makes $69. All right, and then for this one, if I plug 20 in, I'm doing C equals 4.5 now times 20 instead of times 12, so it's 20 shirts, and that makes $90. So now you're noticing, so no shrink tee was more expensive for 12 t-shirts. Now for 20 t-shirts, it's now, or sorry, I think I said that wrong. It's cheaper for no shrink tee for 12 shirts, but it is cheaper at Mighty T if we're getting 20 t-shirts. So somewhere in between there, it goes from being cheaper here to being cheaper here. So we would notice that in our graph, and we're gonna look at that here in just a bit. All right, one more question in the chart. How many t-shirts can we get for $120? So this time I'm given the cost. So 120 would go in for the C in my equation. So I would write 120 equals 49 plus n. Okay, so I'm figuring out the n. So this is just a one-step equation for us to solve. We would just take away the 49 from each side